Hello again. For this lesson, we're going to focus on another important part of designing a quality study. So once we have decided what our research question is, we know what data we want to be collecting, now we have to figure out, okay, who are we going to collect that from? Okay, and to do this, we're going to use the sampling. Okay, there's various sampling methods, but before we start talking about some sampling methods, first thing we need to understand is the difference between a population and a sample. So anytime that we are doing a study, the population is the entire collection of people, places, things, or ideas being studied. Okay, so population is, and we'll emphasize that, the entire collection of entities or subjects being studied. Okay, so that's important. The population is everyone. Now, it's typically not feasible or even possible to collect data from an entire population. If I want to do research on stats students and my population is all statistics, college statistics students in the entire United States, that's not even a manageable thing. It's not going to be possible for me to talk to every single stats student in the entire US. So, which, keep in mind, the name of our class is statistics, right? Statistics involve samples, not an entire population. So that brings us into this idea of a sample. A sample is a subset of the population. So even though I can't feasibly talk to every stat student in the United States, I could get a sample of stats students in maybe Utah, or maybe I could randomly choose a few universities throughout the United States and choose some stats students from each of those, right? So I can get a subgroup that is manageable, okay, feasible to do for a study, and then I'm going to use data from my sample to try and glean some important information about the entire population. Now, if you draw that sample well, appropriately, then that sample can reasonably be representative of the whole population. We can come up with some pretty strong conclusions that are generalizable to the entire population, okay? But it's important that you gather that sample the right way. Okay, so a couple other terms, again, before we get into what the right way of sampling is, we need to understand the difference between a parameter and a statistic. Well, the parameter refers to the population. A statistic refers to a sample. Okay, specifically, there is some specific measure that applies to either the population or the sample. Okay, so when we talk about a parameter, that's a calculation or a measurement that we have gotten from an entire population. When we talk about a statistic, that's a measure that we've gotten from just a sample, typically for use in a study. All right, so remember those connections. So a parameter and statistic, they can kind of be the same calculation. It's just what it's calculated from that matters. So I could be doing an average, and if I do an average of the entire population of data, then that average is a parameter. I could do an average, and if I just do that average from the people or entities in my study, in my sample, now that average is a statistic. Okay, that makes sense? All right, so let's proceed. Now we can start getting into what is the right kind of sample. Now, even though it's not always possible to get a truly random sample, depending on what type of research you're doing, who your population is, it may not be possible to get a truly random sample, but the ideal in research is to have a truly random sample. Now you have to be careful because a haphazard sample and a random sample are not the same thing. Just because you didn't plan beforehand who you were going to talk to or give your survey to, that doesn't mean that your survey is random. So you got to be careful. In this class, you can't just throw out the word random. There's specific meanings that attach to that word random. Specifically, two important parts of a truly random sample are that they're selected purely by chance, which that makes sense, right? But the second piece is even probably a bigger one, a big idea, and this is what makes it different from what we typically have thought of random as being in the past. In the context of statistics, a truly random sample must give every member of the population a chance to be selected. That is big. All right, so somehow you need to have an entire list of everyone in the population, and now you use a random number generator or in some form or another to randomly, purely by chance, selecting, say, 30 people from this entire population of stat students. Okay, so it's very important. If it's a random sample, the only way it can be a random sample is for every member of the population to have a chance of being chosen to participate, okay? And then that selection has to be purely by chance. So random samples, again, are the ideal. The benefit is that a random sample is most likely to be representative of the population, and even more important, it minimizes what we call bias in our sampling, right? A selection bias. So a couple items then. First, tends to be representative of the population. Now, you can't have a sample that's 100% exactly the same as the population. But if you're randomly selecting participants, you have a very high likelihood that the sample is representative of the population. And secondly, this minimizes selection bias. Now, if we're not using proper methodology for sampling, and we don't try to get this random sample, the issue is that, you know what, we are all biased by nature. If I'm standing up on my college campus and I'm just going to give a survey to students who walk by, well, some students are probably going to stand out to me more than others. Maybe I'm seeing a student that seems particularly distracted or in a big hurry. Maybe I'm not gonna bother them so much, right? I don't want to help. I don't want to keep them from whatever it is that they're worried about or trying to get to. So I'll probably focus on those that look like they have time, those that seem like they have interests that I can relate to, okay? Maybe students that are going to the math department, I can connect with those, I have more to talk about, and more ways to convince them, yeah, this survey is important, please do it, right? But that's a selection bias. That means I'm not, I don't have the chance of selecting everyone. First, I'm only going to have a chance of choosing those students that walk by me. Maybe some people have classes that are completely on the other side of campus. I won't even see them. They don't have a chance to be chosen to take this survey or to participate in this study, okay? And those that are particularly busy or seem to be in a hurry, maybe I'm biased against them and they don't have a chance to be selected, but they would have probably made our sample a lot better and closer to being representative of the population. Okay, so we can never completely eliminate bias, but we can apply processes and procedures to try our darndest to get the most random sample that we can possibly get so that that bias is minimized. All right, so big ideas, big ideas. So now we get to talk about some of the specific types of sampling that we could come across, that we could use in a study. The simplest and best, well, you got to be careful using the word best. So the one that is often the ideal is just a simple random sample, okay? All a simple random sample is, the best analogy I can think of is you throw everyone's name in a hat from the entire population, and then you just blindly pick out your 30 names or however many you want to participate in the study. Okay, so again, just one big group, the whole population is one big group, and you pull out using some kind of a random procedure, a random number generator. There's functions in Excel or on your calculators that can generate random numbers, and you can use those to help you select this in the most random way possible. All right, so our simple random sample, write this up for you, sampling where every member of the population has an equal chance of being chosen. Okay, and kind of an aside, you're just choosing from one big group. Whoops, there's an R there. Okay, so simple random sample, again, that's the ideal. You'll often just see in stats circles this just abbreviated as SRS. That's what it means, simple random sample. Okay, now maybe having everyone in just one group and then drawing from that group isn't exactly appropriate for your research question. Okay, there are other ways to sample, and these methods you'll choose, again, based on your research question and the type of data that you want to collect, the analysis that you're going to need to do. A second type of sampling, now each of these next types, well, the next few anyway, could have some randomness as a part of it, okay? Ideally, you will make them random somehow still, but it's a slightly different process. So for a systematic sample, this is similar to like product quality testing on an assembly line. It's not feasible for a company's making sporks. Yeah, those cool spoon and forks in one thing, right? A company's making sporks. It doesn't make sense for them to do a quality test to test the quality of every single spork that comes off the assembly line. But they can pull off so many at regular intervals to test, and that will give them a good idea of how the entire batch is going. So that's where we lean on kind of a systematic sampling procedure again. Okay, so for this one, you're going to take, again, everyone in the population. So sampling from where every member of the population is in some kind of a sequential list. List or order or line, right? The assembly line kind of works as that list. And so for this one, if you want to get randomness in this, you'll get it by randomly choosing a starting point. Randomly choosing a starting point. And then you'll just choose every so many of those sporks, right? So I could make this a little generic, then choose every, I'll just use K. K can be any whole number, right? So every kth item in the list. All right, so that would be like on the assembly line, every 10th spork I'm going to pull off, and that'll be tested. Or every 20th spork, or every 50th spork, depending on the quantity and how fast things are going, right? So that gives me a decent subset. I randomly chose the starting point, so that kind of locks in a set, a specific subset of these, right? So there's a sense of randomness there, but in a lot of cases, the systematic sampling is the best choice. Okay, so again, the systematic sampling, everyone's in a list. You will randomly choose a starting point and then choose every 10th or every 20th or every 30th item as you go down that list, or as it goes by on your assembly line. Hey, not too bad, right? Systematic sample, that makes sense. Now, the next two are similar, so pay special attention to how they differ from each other. So both a stratified sample and a clustered sample involve breaking the population up into groups, okay, and then choosing from groups. So for a stratified sample, you split the population into groups. So let's say you split them by gender, okay? So we want both genders equally represented, so we have split our population up into males and females. And once we have our groups, now we're going to choose some of the entities from each or from all groups. Notice I underlined those key pieces because those are the parts that are going to differ when we talk about a cluster sample. Okay, so again, stratified sample, you split the population up into subgroups. They could be whatever subgroups are going to be best to answer your research question, right? In a school context, you can often split up your students in terms of their grade in school. Okay, you can split up students based on the subject, based on their major, right? And then you will choose some from each major. So say I want a sample of 50 total. So I would choose, if I use the male and female groups, I'll choose 25 males, 25 females, and now I know that both genders are represented equally in my study, okay? Or at least in proportions appropriate for what I'm studying, okay? Maybe I want the male and female proportions in my sample to match the actual male and female proportions in my college that I'm researching, right? And so maybe that means I want 30% males, I want 70% females, depending on where I'm at. So that means choose 30 males, choose 70 females. That makes sense? Okay, so stratified, split into groups, choose some from all of the groups. For a cluster sample, you start out in a similar way, right? So you still split your population into groups. However, in this case, so let's say we're splitting up the population. So I want to do research on high school students in Utah. Well, again, I'm not going to be able to talk to every high school student, but some naturally occurring divisions could be their school district, right? District 1, District 2, District 3, District 4, and however many school districts there are in Utah, right? So a cluster sample is often used for when you're dealing with regional groups, okay? And now this is different from our stratified sample in that from each cluster, each of those groups, I'm going to randomly select only some of the groups. So remember, in stratified sample, I used all of the groups, okay? And then I chose some from each of the groups. In this one, I'm only going to choose some of the groups. So let's say that I ended up randomly selecting District 1 and District 4 and District 5. Okay, so I choose those groups, and then I'm going to use all entities or people, depending on what you're studying, in the chosen groups. Okay, so again, look at that difference again. Stratified sample, we split into groups, we use all of the groups, but only take some from each of those. In a cluster sample, I only use some of the groups, but I take everyone in the groups that I choose. Get the difference? Okay, so those are the two most confused that I have seen with my students in the past. So make some mental notes on the differences between the stratified and the cluster sampling. All right, now these last two, depending on the situation, maybe a convenient sample or a voluntary response sample is going to be the most appropriate sampling method. However, with both of these final two methods, you are not eliminating bias very much, okay? These are not random samples. A convenient sample and a voluntary response sample are not random. So do not ever tell me, like for your project in this class or for research you are going to work on or whatever, don't tell me you have a random convenient sample, because that's not a thing. They do not go together. A convenient sample is pretty much self-explanatory, right? So you just select those who are most convenient to select. Okay, so if I'm going to use a convenient sample, I want to select stat students, who is most convenient for me to select from? Why don't I just use my own students, right? They're the most convenient. I already have access to all of them. I already have a rapport with them. However, know that just my students may not be representative of my whole population, okay? It's showing some bias. Every stat student did not have a chance of being selected because I just automatically went right to my own students. Maybe you're doing research and you're just going to ask some questions to your family or just to your dorm mates, okay, or colleagues at work. Those are going to be convenient samples. They don't eliminate bias very well, which means the power of your conclusions, the generalizability of your conclusions is going to be greatly diminished. All right. It may give you an idea of some relationships or that may exist. Okay, so but you can't say very strongly that your observations or your results will apply to the whole population, okay, because of the convenient sample. Same thing for a voluntary response sample. Those are very common in, say, surveys, right? You send a survey just to a bunch of people, and only those who want to respond. Okay, there's our voluntary response. Only those that want to participate do participate. Okay, and again, there's some contexts where a convenient sample or a voluntary response sample are necessary to get a good feel for the waters, to see what directions you want to take things. But again, the best samples are going to be those that are random. And you'll find that more often than not, you'll just use a simple random sample. Everything's easy peasy, okay? All right, so that is it for our sampling methods. So you learned a lot of important things in this lesson. First, you know the difference between a population and a sample. It's not always feasible, usually is not feasible, to get data from the entire population, right? A census gets pretty close, okay? Like the US Census, every 10 years that gets sent around or something. That gets pretty close to getting the whole population. Great, but that's not very feasible usually, okay? So we'll draw a sample. We'll get a subset of the population, preferably in the most random way possible, so that we minimize bias, okay? You know that a random sample means that everyone in the population has a chance of being chosen, and they are chosen purely by chance. Some kind of a random number generator or something like that. And then we spent lots of time talking about the different types of samples. So I hope you filled that in, your own individual prep assignment. If you had a printout or in your notes, those will be handy. All right, stay tuned for the next lesson. I will see ya.